Linear inequalities are inequalities using two variables, x and y. The solutions for a linear inequality are all of the x and y pairs that work in the specified inequality. So our first example is to check the solutions for inequalities. I've got three ordered pairs here. We need to decide, are these ordered pairs solutions to the inequality 2x plus 3y is greater than or equal to 5. To check whether it's a solution, plug it in. So 2 times 0 plus 3 times 1, and we're checking to see if that's greater than or equal to 5. 2 times 0 is 0, plus 3 is 3 greater than or equal to 5? No. So that ordered pair is not a solution. You can write not a solution or just slash through the point and say no. The next one, the point 4, negative 1. Plug in 2 times 4 plus 3 times negative 1, and we're seeing if that's greater than or equal to 5. So is 5 greater than or equal to 5? Yes. So that point is a solution. Next, the point 2, 1. So 2 times 2 plus 3 times 1 is, oops, kind of ahead of myself there, is 7 greater than or equal to 5? Whew. Yes. So that ordered pair is a solution. Now, graphs were not created by mathematicians to torture you. I promise they weren't. Graphs were created to visually represent all of the possible solutions. There's an infinite number of possible solutions for this particular inequality. To see a graphical representation, a visual representation of all of those possible solutions, we graph the inequality. So turn to the next page and let's graph inequalities. The graph of a linear inequality is the graph of all solutions of that inequality. The boundary line of the inequality divides the coordinate plane into two half planes. The shaded region is all of the points that are solutions, all of the points that work. The unshaded region is all of the points that are not solutions, all of the points that don't work. To graph an inequality, we graph the boundary line. We have to think about solid line or dashed line. Use a dashed line for less than or greater than. Use a solid line for less than equal to or greater than equal to. This is basically indicating whether that boundary line is included in the solutions or not. If it's greater than or equal to, that means points on the line work, so it's like we're shading in the line. We're making it a solid line. A dashed line means that points on that line are not solutions because the line is not shaded in. So first, y is greater than or equal to 2. This is y with no x, so this is a HOI scenario. So draw in a horizontal line at 2. Is this horizontal line going to have a solid or a dashed line? Solid line. Okay, it's greater than or equal to. Because it's or equal to, that makes it a solid line. Okay. For shading, y is going to be like all of the possible things that y could be. That's what we have to shade. So y has to be larger than or equal to 2. Where on this graph would our y values be larger than 2? Above it. So we are going to shade above this line. Once you have it shaded, I have a couple questions for you. I know. Is point A that I just drew in here, is point A a solution for this inequality? No, it is in the unshaded region. Is point B a solution? Yes, it is on a solid line, so it's included in the shaded region. It is a solution. And then how about point C? Most definitely it's in the shaded region. Okay, the next one, x is less than 1. Sorry, x is less than negative 1. This is x with no y, so this is a Vux scenario. We need a vertical line at negative 1. Is that vertical line going to be a solid or a dashed line? Dashed. Because there's no equals line, that makes it a dashed line. That means we aren't including the boundary line in the shading. So there's my dashed line. Oops. Shading for this one. Where are the x values smaller than negative 1? On the negative side, which is to the left. Okay, again, I'm going to ask you some questions. Is point A a solution? Is point B a solution? I'm hearing yeses and nos. It's a less than, not less than or equal to, just less than. It's a dashed line. The dashed line indicates that the line is not included in the shading. So because point B is on the line, it is not a solution. Now for the easy one, is point C a solution? Yes. All right. Let's graph number 3. 4x plus 2y is greater than or equal to 8. There are 2 ways to graph this. And depending on how you graph this, there are also 2 ways to determine where you are going to shade. So let's start by graphing it. Based on grading your tests, I'm finding that most of you prefer to graph using y equals mx plus b. Okay? So we're going to take this inequality and rearrange it so that it looks like y equals mx plus b, but with the inequality symbol instead of the equals. We would start by subtracting 4x on both sides. So 2y is greater than or equal to negative 4x plus 8. What would we do next? Divide by 2. So y is greater than or equal to negative 2x plus 4. Some of you are amazing at graphing slope-intercept form. Some of you still need a little teensy bit of work. A teacher in another class taught me this awesome trick. You know y equals mx plus b? B is your y-intercept, b is where you begin. M is your slope, m is how you move. So b is where you begin, m is how you move. Isn't that amazing? That's like mind-blowing, okay? So the other thing that I noticed is most of you are really good at putting your y-intercept on your y-axis. Some of you are still trying to put your y-intercept on your x-axis, and that is definitely wrong. So I've got kind of a massive point right there. So there's our y-intercept. Once we have our y-intercept on our y-axis, we move down 2 and right 1. Next, we need to think about, is this line going to be a solid line or a dashed line? Solid line. Okay. This is how the math books tell you to decide how to shade. We're going to do like we did for example 1. Pick a point and test it. Is this point a solution or not? I like to pick the point 0, 0 because I think zeros are easy to work with. So let's plug 0 in. 0 is greater than or equal to negative 2 times 0 plus 4. So 0 is greater than or equal to 4. Is that true? No. So 0, 0 is not a solution, which means we are going to shade on the other side. The side where 0, 0 is, that's not our solution. We are going to shade this area. Now, there is a shortcut. If you graph using standard form, you must test a point. If you graph using slope-intercept form like we did, there's a shortcut for how to shade. Greater than and greater than or equal to, we're going to shade up. Less than, equal to, we're going to shade down. Greater than, bigger, up. Less than, smaller, down. Now, if the line is super, super steep, it might be difficult to see which way's up, which way's down. So here's the trick. Put your pencil anywhere on this line and draw an arrow straight up following the grid lines. Whichever side of the line that arrow is on, that's the side that you shade. So even if you have like a super, super crazy straight, like very, very steep line, put your pencil on the line, draw an arrow straight up, and that will show you which side of the line you need to shade. Okay? Now, if it's a vertical line, then you have to shade left or right. It doesn't quite work with vertical, but whatever. Number 4. Let's try number 4. First, to get it into slope-intercept form, we need to subtract 3x on both sides. What does that leave us with? Negative y is less than negative 3x plus 3. How do you get rid of that negative in front of the y? Divide by negative 1, and because we divided by a negative, we switch the sign. Y is greater than positive 3x minus 3. Take a moment, graph that line, think about solid or dashed, think about your shading. Either test a point or think about the shading up or down. Okay, so here's our equation, and my line is kind of difficult to see, but this is, this is a dashed line. Make sure that's obvious. Okay. Now, a couple questions for you. Is point A solution? No. Is point B a solution? Is point C a solution? It's hard to see up there. Yes. Now, I did the shading by shading up. But you can also test a point. If you test 0, 0, 0 is greater than 3 times 0 minus 3. 0 is greater than negative 3. That is true, so 0, 0 is a solution. Notice the side of the line that 0, 0 is on is shaded. In this problem, CDs cost $10 each, so 10x. Music videos cost $20 each, so 20y, and we can't spend more than 200, so less than or equal to 200. We solve that, get it into slope-intercept form. Y is less than or equal to negative 1/2 x plus 10, and graph it. Solid line shaded down. 3 possible solutions for this real-life situation. I could use this point. This point is 0, 10, and it indicates 0 CDs and 10 music videos. This point right here is 2, 3. And it indicates 2 CDs and 3 music videos. And you could go on to describe other situations based on this graph. But that shaded area shows you all of the possible combinations of CDs and music videos that you could buy and still spend $200 or less.